topic is electric energy. What do you mean by electric energy? See, there are plenty of electric devices. Understood? Not only bulb, not only electric bulb, heater, etc. The fridge. Understood? Fridge is there. Washing machine is there. Air conditioning is there. The bulb, actually what happens, the bulb convert the electric energy into heat energy. Understood? The bulb is actually doing, what is actually bulb doing? The bulb actually convert the electric energy into heat energy. Understood? Heat energy. Because of heat energy, there is a brightness. That's all. And iron box, electric iron, serve the same purpose. The iron box convert the electric energy into heat energy. Iron box, electric heater also doing the same thing. And what about fan? What about fan? Is it actually converting electric energy into heat energy? Tell me. What the fan doing? Is the fan just simply convert the electric energy into heat energy?
Electric energy into wind energy.
The electric energy into mechanical energy. We can say like that. Electric energy into mechanical energy. See, because the fan is rotating, right? The fan is rotating. The mechanical energy is required. Actually, the electric energy is actually converted to mechanical energy. But on the other hand, the bulb is, what is bulb doing? Bulb convert the electric energy into heat energy. Understood? So you understood. So electric energy can be converted to different ways. Heat energy, mechanical energy, like that. So electric energy, I am talking about electric energy. Electric energy is equal to electric energy. We studied yesterday the same formula, exactly the same formula we will use here. Electric energy is simply equal to PT. We studied yesterday the heat is equal to PT, right? Heat develop in T seconds. Heat develop in T time is PT. Exactly the same formula. Because in the case of bulb, the electrical energy is converted to heat energy. So this emitted heat is actually electric energy. This emitted heat is actually another form of electric energy. Understood? So the heat energy is actually a conversion of electrical energy. Heat energy is actually a conversion of electric energy. Understood? So in general, electric energy is equal to PT, where P is the power. I explained already, but let me write the formula once again. P is the power. Power is actually the work done by the electric device. Work done in unit time or in seconds. For example, what is the power of fan? What is the meaning power of fan? The fan is doing some mechanical work, isn't it? Fan is doing some mechanical work. How much work is done by the fan in 1 second? Understood? How much work is done by the fan in 1 second? That is power of the fan. Understood? Power of the electric bulb. How much heat energy is developed in 1 second? That is power of the bulb. So in general, power is actually the work done by the electric device. Work done by the electric device in unit time. And T stands for time. We know that. So electric energy is equal to PT. P is the power. Okay. So now remember the unit of electric energy. Unit of electric energy is, one unit is, normally we use the unit joules. Electric energy has the unit joules. Another unit is, the first time you are hearing this, another unit is watt hour. It's very, very important. The second one is the most important unit, watt hour. Watt hour. WH, watt hour. In domestic purpose, in our house we are using electric energy, right? We are using electric energy for working fridge, AC, electric bulb, fan, etc. After 1 or 2 months we get the electric bill. After 1 or 2 months we get the electric bill, in which they mention the unit as watt hour, not joules. In the bill they write the electric energy, electric units in terms of watt hour, not joules. So industrial purpose, for industrial purpose, the unit of electric energy is not joules, it is watt hour. Why watt hour? Watt hour means the power has the unit watt. Here when if you want the unit in watt hour, the time should be hour. Understood? If you want this unit, the power should be watt, time should be hour. Time should be written in terms of hour. So power has the unit watt, time has the unit hour, so watt into hour. Watt into hour, watt hour. Understood? So you please remember that. So okay, you please write down. There are important questions based on this. This is a very important question. You can expect one question like this based on this. This is actually based on electric energy, okay, not a different one. Based on electric energy, I will discuss that. You can expect one question based on this. Let me read the problem. Let me read the question. A little bit hard, but listen carefully. An electric refrigerator rated 400 watts. What is the meaning of that? An electric refrigerator rated 400 watts. Meaning that the fridge is doing work. What kind of work is done by the fridge? Cooling purpose. Understood? Cooling work. The cooling work, it requires energy, right? Cooling work requires energy. An electric refrigerator rated 400 watt means in 1 second. What means that? In 1 second, the fridge is doing 400 joules of energy. In 1 second, fridge is doing 400 joules of work. So power, okay, 400 watt is nothing but it is power. In 1 second, fridge is doing 400 joules of work. 8 hours per day, the fridge is operating 8 hours in a single day. You understood the meaning? The fridge is on. The fridge is on for continuous 8 hours in a day. The rest of the time the fridge is not used, it is off. 8 hours per day. What is the cost of electric energy to operate it for 30 days at rupees 3 per kilowatt hour? I will discuss, don't worry, kilowatt hour. Whatever I discuss, right? I will explain this last sentence, don't worry. Listen. So what is the cost of electric energy to operate it for 30 days? We are operating the fridge for 30 days. Total number of hours. Let me write the total number of hours. In a single day, the fridge used 8 hours in a single day. So for 30 days, what is the total hours of use? 30 into 8 hours of use. Because in a single day, 8 hours is used. So 30 days, 30 into 8. 240 hours. The fridge was working for 240 hours in a month. In a month, the fridge is operating 240 hours. Next, the electric energy consumed, right? Electric energy. Let me find out electric energy. The fridge consume how much electric energy? Or how much work is done by the fridge in one month? Or how much electric energy is consumed by the fridge? Electric energy, we have a formula PT. Just memorize PT. It is not difficult to memorize. I want watt hour, right? I want the answer in kilowatt hour. So the power should be in watt. The power should be in watt. And time should be hour. Then only watt hour I will get. Understood? I don't want to convert time to second, then I will get only watt second. Do I need watt second? No, I want watt hour. So the power should be in watt, time should be in hour. On multiplication you will get the unit as watt hour. Then kilowatt hour we can easily convert. Watt hour can be easily converted to kilowatt hour. That I will discuss later. So power should be watt, time should be hour. If the time is given in minute, you must convert it to hour. So electric energy is PT. P is 400 watt. You may write the unit along with that. You will not get any confusion then. Time is what? 240 hour. 240 H. H stands for hour. Let me do the multiplication. 1 minute. 400 into 240. Let me do the multiplication. 400 into 240. You will get 96000 watt hour. WH means watt hour. I want the unit in kilowatt hour. Kilo stands for 1000 actually. Okay, if you don't know, please write somewhere. Kilo stands for 1000. For example, 1 kilogram is 1000 gram. Understood? 1 kilometer, 1000 meter, like that. Kilo stands for 1000. So 96,000 is 96 into 1000 watt hour. Can I split like this? 96,000 is 96 into 1000 watt hour. Is that okay? I just split like this. In that 1000 stands for kilo. 1000 is denoted by the letter K, kilo. 1000 is denoted by the letter K, kilo. 90 says this 1000 is denoted by the letter kilo, K, watt hour. So all the electric bill will be according to this unit, kilowatt hour. In the electric bill they write 96 unit of electric energy is consumed. 1 unit stands for kilowatt hour. Or for all industrial purposes, kilowatt hour is the unit of electrical energy. So not finished yet. Now this much unit is used in a 1 month. Was the billing. The next is about billing. 1 kilowatt hour. If I spend 1 kilowatt hour electrical energy, I have to pay 3 rupees. If I consume 1 kilowatt hour energy, I have to pay 3 rupees for that. So I am using 96 unit of electrical energy. So the total electricity bill, total cost will be 1 kilowatt hour. The cost is 3 rupees. Hence 96 kilowatt hour cost will be 96 into 3 rupees. 1 kilowatt hour 3 rupees. So 96 kilowatt hour, 96 into 3 rupees I have to pay. So 96 into 3, let me do the multiplication. 96 into 3, 288 rupees will be the bill. Okay. Let me make some modification in the question. You have to send me the answer through WhatsApp. Look at this question. An electric motor takes 5 ampere from 220 volt line. Electric motor is actually doing mechanical energy. Understood? It consumes energy. It converts electrical energy into mechanical energy. Determine the power and energy consumed in 2 hours. Very simple question. It's a very simple question. So what happens? Our objective is power. The first question is about power. Power has the formula VI. You studied in the previous class. Power is equal to voltage into current. In 1 second, how much work is done by the electric motor? Electric motor is doing work. 1 second, how much work is done? Power is voltage into current. Figure is not required. Voltage is 220 and current is 5 ampere. The product will be 1100 watt. The first part is over. It's a very simple question. Only these type of question will be asked, and I will discuss the indirect question later in the next class. The second part is what? the energy, how much energy consumed by the motor, or how much work is done by the motor in 2-hour time. Energy is equal to PT. I told you, memorize this formula, PT. Never forget it. Energy, electrical energy, PT. Power, I just now found it, 1100 watt. You please write the unit. Time is 2 hour. 2h. You need not convert to second, or you can decide. If you don't convert to second, you will get the unit in watt hour. Watt hour is a standard unit. So 1100 into 2 will be 2200 watt hour. You may write it in kilowatt hour, but not required. Watt hour is a standard unit. Okay, but kilowatt hour is the most appropriate unit. So kilowatt hour, let me explain that. 2.2 into 1000. 2.2 kilowatt hour is the most appropriate unit for electrical energy. Is that correct? 2.2 into 1000. You check it. 2.2 into 1000. Yes, it is 2200. This 1000 is denoted by K, kilo. 1000 is denoted by K. 2.2 kilowatt hour. Is that okay? Clear? Understood?
Yes.
I will discuss that. Let me write somewhere. Let me write here. 2 hour is equal to 2 into 60 minutes. You agree with me? 1 hour is 60 minutes. You know that. 1 hour is 60 minutes. So is that correct? 2 hour is equal to 2 into 60 minutes. Now minute, 120 minute. Okay, that is okay. 120 minutes. Let me write some extra steps. 120 minutes. And 1 minute is 60 seconds. It's very simple, right? 1 minute is equal to how much second? 1 minute is 60 seconds. So 120 minute will be 120 into 60 seconds. You will get a larger value if you want the answer in joules. 120 into 60 will be 7200 seconds. So hour can be converted to second. First hour should be converted to minute. Then that minute should be converted to seconds. So if you want the answer, please note that the time should be in seconds. So 2 hour is actually 7200 seconds. Watt power is watt itself. There is no mistake in that. So watt second is actually denoted by joule. Remember, this watt second is actually joules. So 1100 into 7200. You will get much larger value. 1100 into 7200 will be 792000. Watt second is joules. Just keep in your mind, for joules you must convert the hour to seconds. So please try this question and send me the answer through WhatsApp. Units. I want the answer. Please send me within 2 minutes. Let me discuss one indirect question. This question is not there in NCERT, but this question is asked in board exam. Let me draw the diagram. You have to learn the previous classes, okay? We have 2 bulb. The question was asked like this. A figure will be given to you. A figure will be given to you. Based on this figure, you have to answer certain questions. This voltage is 200 volt. This bulb has resistance 100 ohm. This bulb has resistance 50 ohm. Let me give a good number, 3 volts. So this type of question is important. I have gone through the previous year questions. I have seen plenty of questions like this. This question is not there in textbook. All of you please listen. Please listen carefully. Voltage is given, battery is given, two bulbs are connected in series. Two electric, this symbol is represents bulb actually. Two electric bulb having different resistance connected in series. Question is, so there are two bulbs, understood? There are two bulbs. This is first bulb and this is the second bulb. Their resistance are different, their brightness will be different. The question is, find question number 1, total resistance. You studied in the previous classes, I don't know whether you remember or not. The first question is, the question will be like this. Based on this diagram you have to answer certain questions. Find the total resistance. Second question is, find the current, circuit current. Actually 1 and 2 I have already discussed. Circuit current. Find the power of each bulbs. Power of each bulb. These are bulb actually. Find the total power. Or find the power delivered by the supply. Let me change. Let me make some modification in the sentence. Find the power delivered by the source. These type of questions are very, very important. It is not a tough question, but this type of question is not there in textbook. That's why I've discussed this. Listen carefully. This is not it is actually a simple question. Don't worry about this problem. Very simple one. Two resistors are connected in series, right? Bulb is actually having certain resistance. Two resistors are connected in series. The total resistance or effective resistance, you studied that it will be sum of the resistors. If R1, R2, R3 etc. are in series, the total resistance we studied in the previous classes, R1 plus R2. It was the first question, that is why. R1 is 100 ohm, R2 is 50 ohm, it will be 150 ohm. This is the total resistance, don't forget it. So next is, the first question is done. Now the second question. Find the circuit current. This is R is actually effective resistance. We studied another formula for effective resistance. I discussed that. I think you forgot it. The effective resistance has the general formula. What is the general formula of effective resistance? This is the general formula, battery voltage. Let me write it in words, by battery current. Battery current means some current is starting from the battery, right? Some current will be starting from the battery. That is said to be battery current. So please never forget it. The effective resistance has a general formula. Whatever may be the circuit, the effective resistance has the general formula, battery voltage by battery current. Okay, never forget it. The effective resistance I got 150. Battery voltage I know 300 volt. Battery voltage is 300. But I don't know the battery current. I don't know battery current. Let it be I. The second question is battery current. How much current is starting from the battery? Do the cross multiplication like this. Equal to 300. I equal to 300 by 150. Or I equal to 2 ampere. The battery current I got. Let me write the value. The battery current is 2 ampere. Okay, this is question. So let me delete it. Formula, power equal to I square R. Do you remember this? I explained this in the previous class. I square R1 is the suitable formula. because I is the current passing through the bulb. I square R, where I is the current passing through the bulb. The current passing through the bulb is battery current. The current passing through the bulb is actually I. I is 2 ampere. So this I is 2 ampere. 2 square into R1. R1 is the resistance of the bulb. It is 100. 400 watts. The next is P2, the power of the second bulb, I square R. I square R2, because the power of the second bulb will be I square into its resistance. I square into resistance. The same amount of current is passing through the second bulb. They are in series, so same amount of current is passing through the each bulb. So the current passing through the second bulb is also I. Resistance is R2. I square R2. I square R2, I is 2. R2 is 50. 4 into 50. 200 watts. So the first bulb is 400 watt, but the second bulb is 200 watts. Clear? Question, the total power. There is no space. I will write in the next page. The total power, or okay, no problem. Total power I want. Total power I want. The total power, you simply add the power of each electric devices, that's all. The total power is obtained by power of each electric devices, whether the electric device parallel or series, whatever it may be. If there are more electric devices, the total power is obtained by adding the powers of each electric devices. Always we use this formula. Whatever may be the connection of the supply, whether it is the bulb is in series or parallel, whatever it may be, the total power delivered by the battery is equal to power of each bulbs, power of the each electric devices. So in this case it is only P1 plus P2. P1 is 400. P1 is 400 watt and P2 is 200 watts. So the total power delivered by the source will be 600 watts. Please write down. I will give you one question, you have to answer. Try this question, send me the answer right now.